today's lesson is about financial maths, and I want to start with you guys doing a little bit of fraction stuff. So often we deal with interest, and in this very first exercise, you'll see the writing 6% PA or per annum per year, 7.5% per annum, and 9.63% per annum. I want you to write these interest percentages as decimals. We'll call this A, we'll call this B, we'll call this C. And I want you to write these percentage numbers as decimal fractions, as that's often what we have to do in financial maths. And if you don't get that right, it can affect everything else. So let's just start with that. And you can pop your answer in the chat. And for A, B, and C. I see the answers coming in there from Piwe and Brooklyn, and I see the answers coming in. So the first one is going to be for 6% is 0.06. One of the ways you could have done it is just going 6 divided by 100. And then 7.5%. Or you could write it as 7.5 over 100. And what about C? What do we think C is going to be? So what I want to show you is if you're writing these percentages as fractions, if you use decimals, then 0.06, or what you can do is you take the percentage and you just take the number and put it over 100. Either of these can go into your calculator and they will give you the correct answer. So both of these are valid when you talk about this 6%. Now, what it also means, PA, that means it's this fraction per year. Per annum means per year. So that's how much interest, that much extra you get based on the principal or the whole per year. Okay, well, that wasn't too bad. I liked what I saw there. I would like you now to do the next 5. So this is D, E, F, H. And I want you to write these as fractions like I've done so far. Pop your answers in the chat. I like what I'm seeing, everyone. I like what I'm seeing. Okay. So the first thing we have to get right with financial maths is we need to make sure we can convert a percentage into a fraction. And we also need to take note of how long. So when we talk about interest rate, the interest is the fraction, the rate is for how long. And so this, at the moment, it's per year. Now, what we sometimes have to do is we need to take an interest rate and change it from one time period to another. So if I want to convert 6% per annum to a quarterly interest rate. So sometimes you would say, let's do it with the first one. So we'll say 6% per annum. What would the interest rate be per quarter? So let's try and do that one. We're going to convert 6% per annum to an interest rate per quarter. What do you think my new interest rate would be? So now what we're doing is we're changing it from per annum to PQ, or per quarter. So we had 6% per annum. What's it going to be for per quarter if we do a straight conversion here? So we take what we have here, 6, and how many quarters are there in a year? There are going to be 4 quarters in a year. So 6 divided by 4 is just going to be 1.5% per quarter. Just 1.5%. I'm not going to do the decimal because you guys know how to do that. But can you see how, because it's 4 quarters in a year, I had to divide that by 4. So 1.5% per quarter would be a conversion. Now, I want to do another one like this, except I want the next one to be per month, PM. So what do you think my interest rate per month will be if I'm converting it from an interest rate per year down to an interest rate per month? What's that going to be? So remember, for this one, we seem to go 6 divided by 4. What are we going to do for this one over here? I think we're going to take our interest rate per year, and how many months are there in a year? There are 12. So we are going to get 0.5% per month. Give me a thumbs up if you understand how I went from a converting a year that's per interest rate per year to a per quarter and a per month. Just want to make sure you understand why I divided by 4 for the quarters, divided by 12 for the months. Okay, now that's a very important idea that we just need to get right at the beginning for financial maths. It's going to come up again and again, and we'll just keep coming back to this little example that we started with. Okay, well, related to that, I think we have just told ourselves how many months in a year. Well, there are 12 months in a year. How many quarters in a year? There are 4. How many periods of 6 months in a year, or semi-annuals in a year? There would be 2. And how many days in a year? There would be 365. So if we're chopping interest rates up into smaller pieces, these are the numbers that we would need to divide by. The only other one that I haven't put here is weeks. And how many weeks? Well, they would normally tell you, but I'm pretty sure there's 52 weeks in a year. And so if they were saying an interest rate per week, you would divide by that. All right, now, next question. How many months are there? We're going to have A, B, C, and D again. How many months in 3 years? How many quarters in 5 years? How many 6-month periods in 18 years? How many days in 4 years? I want you guys to work that out for me and pop it in the chats. We're doing nicely, everyone. Very, very nicely. So I see lots of students, Tando, and everyone else has got 36. So they're 36 months in 3 years. Mamelo has said there are 20 quarters in 5 years, and I would say 5 times 4 is 20, so that's good. What about C? How many 6-month periods in 18 years? Well, if there's 2 per year, it seems like we just go. So we would get 36 6-month periods. And then the last one, what's the last one going to be? I might need my calculator, but I'm going to get 4 times 365. What are we going to get for that? We should get 1,460. Okay. And that would be for days. Okay. So sometimes you need to work out what the interest rate is per month or per year or per whatever. And sometimes you need to work out how many of those periods there are. And those are 2 skills that you need to make sure you've got right at the beginning, which from what I'm seeing is everyone's good, but always good to come back to that. Okay, Unati's asked a good question. Could there be an extra day because of the leap year? In theory, yes. But for now, I'm going to say, look, they need to be explicit about whether it includes the leap year. But Unati, a good question. I like it. Okay, now, there are 2 different types of interest that we talk about. The one is simple interest. And to be honest with you, simple interest doesn't actually get used that much in the real world. It's much more common to see something called compound interest. But you need to be aware of the relationships between the different things. So let's just have a quick look at the 2 formulas. On the screen is a summary. I'm going to write it out a bigger. Every financial maths question that deals with growth will have something called the principal, or the amount that you start with. Okay. And then what we have is it's how it grows and then how we get to the final value A. Now, if we're using simple interest, we often say SI. If we're dealing with compound interest, we call it CI. And so I want to start with this part. Now, at the moment, the formulas look the same, but they are really not. And the reason they're not the same is because the method for calculating the values are different. And what we have here for simple interest is we have 1 plus I times N. Okay, where N is the number of years or time period, I is the interest rate per time period, and then that's a 1, and there's that there. Whereas compound interest, it has an N that's an exponent. Okay, and it's the same thing. The beginning, what you start with is the principal. What you end up with, A is the final, the I is the interest rate, and the N is the number of time periods. Now, give me a thumbs up if this looks familiar to you. Give me a thumbs down if this looks unfamiliar to you. Because I'm going to do an example where we compare both of these. Okay. So here's the situation. If I am given 1,000 Rand, or let's even say 1,200 Rand to start with, and I'm told that I can get an interest rate of 10%, okay, and the time period it's going to grow for is going to be 3 years. Now, the only difference is the one bank is offering me SI, or simple interest. So on this side, this is going to be 10% per annum SI, and on this side, it's going to be 10% per annum CI. I want to compare what the difference of growth is, or what the final value is going to be using these 2 different methods. Give me, if everything else is the same, give me a thumbs up if you understand what I'm about to do. So I'm about to compare, if I let 1,200 Rand grow at 10% per annum simple interest, and what I end up with compared to if I deal with 1,200 Rand invested at 10% per annum compound interest for 3 years. I'm basically comparing the 2 different formulas. Okay, so what I'm going to do here is I replace this with 1,200 because I know it's that. Over here, what is my interest rate? It's 10% per annum. So I'm going to write 0.10, or I can write 10 over 100. And then here, I'm going to write 3 because of the 3 for 3 years. And that is going to give me 1,200 times 1.3, which gives me 1560. And what you see is that with simple interest, you got 10% of the original for 3 years, and that's why it's only 30% bigger. Now, with the compound interest calculation, we're still going to start with 1,200. We're still going to have 10%, but now we're going to have a 3 as an exponent. And what that means is that this is 1.1 to the power of 3. Now, what do we end up for that? 1,200 times. I'm getting 1,970.2. Now, out of the two options, which one should we have chosen if we want to be wealthier one day? Which one should we have chosen if we want to be wealthier one day? Okay, Malcolm, Bianca, everyone says compound. And the reason we're saying compound is because this amount is bigger than that amount. So even though the time period was the same, the basic interest rate was the same, or the nominal interest rate, although the way the interest was calculated was different. But everything was the same except the way that we calculated the interest. And what we see is that compound interest grows quicker. Can anybody come online and tell me why compound interest has grown quicker here? Like, why has it got bigger quicker? What's the reason that happens in the calculation? Any ideas? We want to put their hand up, maybe Elichle or Brooklyn or Sichaba. Why do we think that compound interest seems to grow quicker? Let's give you a moment more, then I'll give you an explanation in a moment. But exponential growth, Anati, absolutely. So if you have to compare these two guys on a graph, right? Both of them start at the p-value. But simple interest graph looks like that. It goes up at a steady 10% per year, whereas the compound interest graph, it's actually it's not going to be, it's going to be a curved graph. It actually looks like that. Yes. So because of this exponent, this growth goes up. Another way of saying that is that compound growth has interest on interest. So if you imagine, like with simple interest, you always get 10% of the whole. So each year, so year one, there were 3 years, right? Year 2, year 3. So for year 1, what is 10% of 1,200? You got 120 in interest. Year 2, you got 120 in interest. Year 3, you got 120 in interest. Now, if I add up that 360 and I add it to my 1,200, I get my 1560. So the amount of interest I get every year is still 120. But with compound interest, in year 1, I will get 120 rands interest. But in year 2, I don't get interest on just the 1,200. I get interest on 1,200 and 120, which is, that's how much there is in the bank. And so the interest in my second year is 132. And then in year 3, I get interest on all the interest that I have in my bank account, which is going to be, let me move this out of the way. What do we get? 1,452. And so my year 3's interest is going to be 145.2. And so what we notice is that with compound interest, we get interest on interest, and that's why it starts to shoot up a bit more quickly, because of this effect that I'm showing you here. Give me a thumbs up if that sort of makes sense to you. Give me a thumbs down if that, I know that was a bit, went into a bit much detail, but I think that shows how they're different. Okay. Tando, you have a question. Would you like to unmute yourself? Well, I'll unmute you, sorry. What's your question?
Hi, sir.
Hey.
I'd like to ask, how do we get to 120 interest in year 1, year 2, and year 3?
Okay, so what I did was I said, I've got 1,200 is what I started with. Now,
Okay.
what is 10% of 1,200? What is 10%? Would you agree 120? Like if I went, so I'm just taking 10% of the original. Good question. Does that make sense a bit?
Yes, sir, it does.
And then it goes 120, 120, 120 is the 10% of the original. Whereas with this one, I started with 120, but then in the second year, I actually added that 120 to the 1,200. And then I took 10% of that. And what's 10% of this? Well, it's going to be 132.
Okay, thank you.
Pleasure. Okay, now I don't think everyone have got that. But all I wanted to do is make sure you have some idea of how they're different. Now, let's go and let's look at an example question, and then after the break, we are going to start doing some more of these ourselves. So, typically, compound interest questions look something like this. Craig decides to invest 500 in a bank, compounded at 11% per year. How much will he have after 3 years? And you're going to have 3 of the things given to you. Now, this should say per time period. So this is per year. And all we need to do is then put the values into the compound interest formula. And so the P gets replaced with a 500, the I with 0.11, and the N with a 3. And I get that. Give me a thumbs up if you follow that example. So after the break, we are going to give this a go. Okay. Now, what about another example that looks a little bit different? In fact, I want you to tell me what is different about the second example. So if you read it, I want you to read it. The whole example's on the board, but how is this different from the previous example? How is this different from the, okay. So Morgan has said we have the final amount, or he won 6,000 in 5 years' time. We want to know how much should he invest if the bank offers him 12.5 interest per annum? Yes. So Conke said we're looking for the initial amount. Yes. So what we do is we sub in the 6,000 for the end amount. We sub in the interest rate here, and we sub in the time 5. And what we then do is we have to get the P all by itself. And to do that, we just bring this across. So we divide 6,000 divided by 1.802, etc., and we get that. I want everyone to check this. So get 6,000 on your calculator, divide it by this bit, and say yes if you get this amount here. Okay, so Conke says yes, Sadiq says yes. We're looking for P, yes. Okay, fantastic. All right, let's do one question before the break. Okay, so here is a set of combinations. We are going to find the missing value for each of the following using compound interest. Now, since we're using compound interest, I'm going to put the formula up for you. I want to know, before we have our break, what is the value of A in the very first question? So I want you to work that out for me, and then I want you to put it in the chat when you have got that. So ask yourself, what have you got? Now, this really should tell you per annum. So I'm going to put that in. So I'm going to go with 925. And then I'm going to say 1 plus 0.11. And we're going to get 2. And what is my value going to be? So I end up with 1,139.69. And so that is the final value. And then after the initial one was 925. All right. Well done, Malcolm. Well done, Lungile. What I want everyone to do now is I want us to stand up on our feet. Nicely done, Brooklyn. Also looking good. And I want us to have a bit of a break because I've been talking quite a lot. You've been working quite a lot. And I think it's time that we just have a quick little break for our brains so that we don't overdo things. So let's start with a little twist, a little rotation. And here we go. I'm feeling nice and loose. Oh, I can feel myself unwinding, literally. Okay. Shake out the arms, nice and loose. Get them nice and fluffy. Shake out the legs. Oh, and let's roll the shoulders a little bit. And let our eyes relax by focusing in the distance. And let's change the direction of our rolling. So let's roll forwards. And shake out the arms again. Let's do a tricep stretch. Okay. Switch the other arm. And another shaking out of the arms. Okay, and then let's do some heart rate stuff. Let's do air skipping, and we'll do 20 in 3, 2, 1. And we are done. Okay, I hope that your body feels that little bit more relaxed than it was, and that you are ready for our Maths 24 part of the brain break. So can you get to 24 using any of these 4 numbers? And if you can, I want you to put it in the chat. You can do it, people of the room. Who feels like they know? What do we need to do with the 8 and the 8 and the 6 and the 1? Let's just get one Maths 24 thing today. Let's see how it goes. Okay, so Mbali and Zanele have said 8 minus 6 is 2. And that 2 can be added to 1 to get 3. And then that 3 can be times by 8 to give me 24. Yes, well done. Anyone else have any ideas, things they want to test out before we head back to part 2? Okay, cool. Well, I hope you enjoyed today's brain break. So, second part of the lesson. what I want to go to now is I want you guys to try and find me what P is in this calculation, where this is 5% per annum. So can you find me, if I tell you what the final value is, can you tell me what the initial value was? I'll put the formula up again so that you have that accessible. When this actually should be by itself there. So we should have. Now, what some people like to do is they say, look, I can move this whole thing to the other side and just say 3,600 divided by that gives me P. So I'm going to use my calculator. And what I get is 2961.73 if we're rounding to 2 decimal places. Okay, well, I'm definitely getting those answers coming through, which is fantastic. Let us go for this one. Can you get the third one? Can you find me the interest rate? If the initial value was 750, the final value was 1,000. Can you figure that one out for me? We have a bit of a problem here. We might need some help because the I seems to be locked away. What should we do to try and, what would your first step be here? I know that I want to get what I is, but it feels like it's locked inside this. Anybody want to give us a suggestion? What would we do to solve this, to get I by itself? Change exponent. Okay, cool. We definitely have to deal with the exponent. Tegavatso says divide by 750. You're right. So if I move the 750 across, I then have this thing over here as 2.5, or some people would write it as 5/2. But now we need a way of getting rid of something to the power of. Now, what I think is, if I raise, there's a couple of different ways we can do this, but I think if I think of raising it to, look, okay, let me put a bracket around this. I know I have to get rid of this thing, and I've put the red brackets to help me. Now, if I raise this side to 1/2.5, and I raise this side to 1/2.5, we can all agree that if you do the same thing to both sides, it stays the same. Okay? And yes, another way of doing this would be, instead of saying to the power of 1/2 what you could also do, and I agree, is you take the root of both sides. But the question is, you're not going to use the square root, are you? What are you going to use? It's not to the power of 2. It's going to be the 2.5 root. Okay, so you root both sides by 2.5 to get rid of the 2.5. And then I'm going to get 1 plus I equals something. What is that something going to be? Keep those answers coming, ladies and gentlemen. So if I go, I'm going to go shift root, then 2.5 on the outside, and then on the inside fraction button, 1000 over 750. And I get 1.12195, and so on. But when I take away 1 from that, then my I is going to be 12195, and so on. And normally, if we write it as an interest rate, we write it as a percentage. So at that point, it would be 12.20% per annum. Yeah. Give me a thumbs up if you followed that. Give me a thumbs down if you didn't follow it. Okay. Awesome. 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 Now, what I want to do is, for those who didn't get it, don't be afraid to go back and look at this part of the lesson again in the recording. The main idea is we needed a way to deal with the 2.5. And what we did was we took the 2.5th root of 2.5. Okay. Now, I'd want to do a couple of questions like this with simple interest as well today. So you get to see both. Most of our time in grade 11 is on compound interest, but it's important that you understand a little bit about simple interest as well. So I'm going to put the formula up, and I would like you to find what N is in A. I'd like you to find what A is in B and what P is in C. But this is for simple interest, and so you need to use a different formula. Now, while students are working on the simple interest calculations, I would like to invite questions from those students who are unsure about how I just did this one over here. So if you put your hand up, and we can have a chat while other students are working on the first 3 questions of the simple interest part. Or you can just ask a question in the chat. That's also fine. Okay, let's unmute Reda Bukhari. Can we unmute Reda Bukhari? Can you hear me?
Yes, I can hear.
Yeah, go ahead. What question do you have about the previous question?
I wanted to ask, like, where did the one go after we used the square root to remove the 2.5?
Okay, so we're looking at this step over here.
Yes. Yes.
Okay. If I take away 1 from both sides, what you'll notice is that at the moment, this has a 1, whereas on the next line, it has a 0. So what I did was I took away 1 on this side, and I took away 1 on that side, and it knocked this one out. And so that's why I'm only left with an I, and then this becomes 0.121955. Does that make sense?
Okay. Okay.
Perfect. So that's, and then I got the I by itself, and then what I did was I said that's a decimal, but if I write it as a percentage, I would just times it by 100, and then I've got that over there.
Okay, sir. Thank you.
Pleasure. Thanks for the question. So let's have a look at this first one here. So I'm going to put 500 equals 210, 1 plus, and then I'm going to have 0.093, and then n. And I need to get this by itself. So I'm going to get 1 plus. And I guess I have to do the same trick again where I take away a 1 from both sides. So what do I get? 510 divided by 210 minus 1. That seems to give me 10 over 7 equals 0.0093. Now, what do I need to do to get the n by itself? What do I need to do to get the n by itself? Tell me, Morgan, what do you think we need to do? I think you have an answer. What did you do? Oh, let me go to, I see Tando's hand is up. Sorry, Tando, maybe you had the answer. No, did you have an answer or the question?
A question, sir.
Go ahead, yeah, cool.
Regarding the question before this, how do you punch
Yeah.
the 2,5 square root of 1,000 over 750? Because I get
Okay, your calculator.
so,
Okay, do you have a Casio or a Sharp? Which calculator do you have?
Casio.
Okay, can you see the shift button, which is yellow? Hit the shift button and then look at the button that are next to x squared. You'll see a shape that looks like a, so you hit shift and you hit the button like X block. And you'll see that there's, do you see that one?
Yeah.
Like it looks, yeah. So you use that one. It looks a bit like this. And what you do is you put inside here, you hit the fraction button. So you have fraction button in here, and then outside you have 2.5. Okay.
Okay.
Cool. So
Thank you.
I see Morgan has helped us out there. You're quite right. You divide both sides by 0.093. And this is where my calculator is going to help me. So what are we getting for n? I suppose I should use my calculator again. So I go 10 over 7 divided by 0.0093. So I get my n is a bit weird. Why is my, okay, let's have a look. 10 over 7, I just write. That's out there. What do you guys get for your, just make sure I typed the other one right. So 500 over 210, and then minus 1. I get 29. It's not 10 over 7. Yeah. So I think that's where I made my mistake. Let me make that. 500 divided by 210 minus 1. I get 29 and 21. Now, where did I get the 0.093? And that also is a mistake. Apologies, guys. Yep. So you get 0.93n. And can you see how easy it is to make a little mistake? Thank you so much. So we should have here 0.093. And hopefully then we get a better answer. Let's have a look. What are you guys getting? Sorry, everyone. What are you getting as your answer for 14? I mean, for n. I think I lost a couple of you there. Yes, Sadiq, I got the same thing. Yep. So 14.9, and that's going to be 14.9. How did you find oh, no. Oh, okay. Tahara, we deal in compound interest, we deal with something called logs, and you learn about that in matric. So it's not in the syllabus at the moment. Now, if it's 14.9, in financial maths, we're going to round this. So this is going to be approximately 15 years. Okay. So we're going to round up to the nearest year because it asks us in terms of years. Okay. Sorry about that, but you can see how a little error, you could see how when I made the error, I got an answer that didn't make sense, and I had to trace my error back to this bit. So just give me a thumbs up if you understand where I made a mistake, and that you are all understand now. Give me a thumbs down if you still feel a bit lost. Okay. Awesome. Let's finish these last two and then we'll call it a day for today. Today was just our introductory lesson. So we are trying to find A in the second question and we're trying to find P in the third. And then once we've done that, we'll wrap it up for tonight. Just to, we've gone over the basics of financial maths. We've looked at simple, we've looked at compound, and then we'll go from there. So my calculator says all of this becomes 41 over 25.
Sir,
Yeah.
the 360 is actually the
Oh,
P.
yep,
Yes.
You're quite right. Thank you. Well spotted. So you get 360. I want to get what the A is. Times 10. And then what do we get for that? $590.40. So if you start off with 360 and you get simple interest of 6.4% per annum for 10 years, you end up with that. Okay, last question of the day. Now we get to the one that I was thinking about, which is how do we get backwards to P? You don't have to do the step that I'm doing here. I'm just showing it to you just so you can kind of see. What are you guys getting for your final p-value? I get 1641.41, and that would be our initial value that we start with. Yeah. Okay, everyone. I have enjoyed teaching you today.